Welcome. We're going to be writing equations of quadratic functions. First up, let's write equations in vertex form, given vertex and a point. So if you want to write the equation in vertex form, you got to know the vertex and you got to know a point. All right, so using vertex formula for a quadratic function, y equals a times x minus h squared plus k. We've got that written down. We're going to replace h and k with the x and y coordinates of the vertex, and we're going to replace x and y with the x and y of a point. Our goal is to solve for a, that coefficient in front of our something squared, the one that tells us the direction of our parabola, whether it's concave up or concave down, and how wide our parabola is. All right, so I'm going to plug in, and I think it's a good idea to write the x and y under the point and the h and k under the vertex. It's really easy when you're writing things down, even when you know the steps, to accidentally write down the wrong value, just because you're looking for the values there. So 4 goes here. So this is step 1. 4 equals a, that's what I'm solving for. And then x is -1. H is -6, so that's going to be minus a -6 squared plus 3. And we just kind of take a look back, get h in the right spot, k in the right spot, x in the right spot, y in the right spot. Because we don't want to take the time to solve and then realize, whoops, I switched 2 values. All right, so we have 4 equals, so now our step 2 is to simplify in our parentheses. So 4 equals a times, so that's going to be -1 plus 6 plus 3. All right, we're going to keep simplifying in the parentheses, because our goal right now is to solve for a. So we have 4 equals, that's going to be a times 5 squared plus 3. Well, we know 5 squared, that's 25. Now this is a coefficient in front of a. So normally when we write coefficients, right, we put it in front of the variable. So this would be 25a plus 3. Kind of running out of space here, so I'm going to kind of move over to the other side. All right, so we're trying to solve for a. All right, so we have to continue isolating a. We're going to subtract k. So we're up to subtract k in those steps there. So we're going to subtract 3 from here. There we go. And subtract 3 from here. And I'm going to write it over a little bit. So that's going to give us 1 equals 25a. And now our last step is to just divide by the coefficient in front of a. Right, so that means 1/25 is equal to a. Our very last step, step 3, is to replace the a with the value we just found, the h and the k with the vertex, and we have the equation of our parabola. So y equals 1/25. X, we know that's minus a -6 is going to be plus. X plus 6 squared plus 3. I could also, if I want to put it in function notation, write it as f of x equals 1/25. X plus 6 squared plus 3. So you can use either y or function notation. They're both correct. Let's move on to the next one. So we wrote the equation of a parabola, given the vertex and a point in vertex form. Oh, and by the way, this was in your notes, so make sure you write that down, and if you need more time, just pause the tape. Our next one is in intercept form. All right, so writing equations in intercept form, given x-intercepts and a point. All right, so now we have to be given the x-intercepts and another point so that we can solve for a again. All right, so using intercept formula for quadratic equation, y equals a times x minus p times x minus q. You're going to replace p and q with the x-intercepts, so not the 0, but the x value. So that's going to be p, and that's going to be q. And replace x and y with xy of a point. Right, so I like to label the p and q, so I put the right value in. Right, so we're going to replace y with a -4. We're solving for a. We're going to replace x with a 4, p with a 1, And then we got another x, so that's still going to be a 4. Right? Every x is going to be 4. And then our q is 7. All right? So that's step 1. Step 2, using inverse operations, you're going to isolate a. So we'll simplify each of the parentheses. We'll multiply the values together. And then we're just going to divide both sides by that value to isolate a. So we have -4 equals a times 3 times -3. Well, that's going to be -9 when we multiply, right? So we have -4 equals -9a. Now I just divide both sides by that value to isolate a. Those negatives will cancel, so 4/9 equals a. I think writing in vertex or in intercept form is even easier than vertex form. I'm going to write that a little nicer off to the side here. So 4/9 equals a. I think that's a little bit easier to read. So now we're up to step 3. So in vertex form, we replaced HK. We're going to replace PQ. Right? So in our intercept form, y equals a times x minus p times x minus q. We'll just replace the p and q with the x-intercepts and a with the value we just found. So y equals 4/9 times x minus 1 times x minus 7, and we're done. And alternatively, we could also write it in function notation. F of x equals 4/9 times x minus 1 times x minus 7. And there, it's just that easy. And so notice it doesn't matter, you know, if I can give you a really complicated value for a. You're just solving, right? And that's not so difficult to solve for a. Let's do a couple more. And this one was also in your notes. And on to the next problem. Our next problem is on a graph, if it ever changes the page. Yeah, there we go. All right, so writing equations from a graph. The steps are the same, except you have to identify a point on the graph. Make sure you choose a nice clear point. Now for vertex form, you need the vertex and a point. I'm just going to label the vertex and a point. Right, so the vertex here is at -1, 4. And I could choose any of these points. I think I'll take 0, 3. That's a nice point. But I could also have taken one of the other points, -3, 0, or 1, 0. Let's just use 0, 3. But no, you can use any point you want. It doesn't have to be a specific point for x, y. It does for the vertex. That's got to be the vertex. All right, so now let's write down our vertex formula. That's going to be y equals a times x minus h squared plus k. So let's replace the x, the y, the h, and the k. So we have 3 equals a times, and this would be a 0, minus a -1. So we know minus a -1, that's going to be plus 1. So I'm just going to write in plus 1. And then k is plus 4. All right, so now let's simplify in the parentheses. So 3 equals a. Well, that's just going to be 1. And 1 squared is still 1. All right, so that's just 1a. I don't even need that 1. But I'll just put that in there just to show you that's 1. So now all I have to do is subtract 4 from both sides. And -1 equals a. Now, does that value make sense? Well, a parabola is concave down. So a has got to be negative, right? So we're expecting a negative value for a. Right, now let's write that our equation, our very, very last step. Right, so this was the step 1. And then right away we were on to step 2. Step 3, let's write the equation. Right, so we just replace the h, the k, and the a. I won't write it again, the vertex formula, because it's right there next to number 1. So we have y equals, and our a is 1, so I don't even have to list, excuse me, our a is -1. I have to list that one. I don't know why I was thinking 1. Maybe I was looking at our I don't know, the 1 right there with the 0 plus 1. Yeah, that's good enough for a negative. It's not too crooked. All right, so we absolutely need our negative there, right? Our negative 1. You don't have to write the 1 part. You can just write negative. And then now we just write the rest of our equation in vertex form. So we have x, and then we're going to replace the h with a negative 1. So minus a negative 1 gives us a positive 1. And we're going to replace the k with 4. And there we go. There's our equation in vertex form. Let's do the same thing, but let's find our equation in intercept form. All right, so step number 1, we need intercept form. So that's going to be y equals a times x minus p times x minus q. Since I've already labeled 0, 3 as xy, let's just use that point again. Right? And now we can use the points. We need to use our x-intercepts, negative 3, 0, and 1, 0. And one of them has to be p, and the other one has to be q. By the way, if I wanted to, I can use the vertex, negative 1, 4, as my xy, right? Because now I'm not using the vertex. This is intercept form. Intercept form doesn't use the vertex. But 0, 3, that looks like a really good point. And it's already labeled, so let's just use that one. So we have 3 equals a times, so we have 0 minus a negative 3 times 0 minus 1. That, something to our negative there, minus a negative 3, well, that's just positive 3, right? So we have 3 equals a times, now 1 plus 3, that's just 3. And then 0 minus, did I say 1 plus 3? 0 plus 3, that's just 3. And 0 minus 1, that's just negative 1. So now we're going to multiply those values. Those will be our coefficient in front of a. So we have 3 equals negative 3a. We'll divide both sides by negative 3, and we get negative 1 equals a. And of course we would get the same value, right? Because it's the same equation, right? So a is the same graph we're working with. It's just a different format, right? Just a different format for writing our equation. But a is not going to change. It's still going to be negative 1. So our last step is to write our equation in intercept form. So y equals negative, and then our x-intercepts. X minus a negative is going to be x plus 3, and then x minus 1. And there we go. We're all done. There's our equation in intercept form. And instead of y, if you want, you can use f of x. All right, so see, it's just a plug in, remembering the formula, plugging the values in, and simplifying, and writing your equation. And make sure you always solve these algebraically. Let's take a look at this one. I think this is our last one. So we're going to write the equation into vertex form and standard form. Vertex form and intercept form. And just to show you that how to write it in standard form, we're going to convert the vertex form and the intercept form to standard form. And we should get the very same equation, right, in standard form, because the vertex and the intercept are just describing the same graph. And when we simplify them, they'll give us the exact same equation in standard form. Now, I don't rewrite my equation into standard form unless I have a reason, because that's extra work. Right? And I really like that vertex form and intercept form. That's really easy to work with. But let's say that was, on a homework you were asked to write the equation now in standard form. Or what if it was on a benchmark or a test? Right? So you want to be able to change the format to standard form if you need to, but you don't have to change it, right? Unless it's something where you're asked to find it in standard form. All right, so let's write our equation in vertex form. So we should identify our vertex. All right, well, you think I could have chosen a prettier value? Now, after saying earlier, don't estimate, we're going to have to estimate, right? We don't really have any other choice, right? So I'm going to make an assumption that that does look like it's going to be about halfway. And let's go with that, right? Because we're learning how to write the equations, right? So oops, that's not negative 3. Let's just do our best here. All right, and not focus too much on whether we might be a teensy-weensy bit off, because we're still learning to write the equations. So this looks like that might be right at negative 1/2, and I say for our purposes here, close enough. Right, so with the vertex, writing this equation in vertex form, we have to just estimate the x and y coordinates of our vertex the best we can. Right, so negative 1/2 is the x coordinate, and then so we're a little less than negative 3. It looks like we're about halfway. So we want to change that to halves. Right, so negative 3, that's 6 halves. And if I add one more half, I'll be at 3.5, because we don't want to use mixed numbers. That's very confusing in algebra. Then it looks like it might be multiplication. So this is going to be negative 7 halves. All right, so that's still 3.5. So that's our vertex. All right, and now we need another point. Now, even though I'm going to use the y-intercept again, know that you don't have to use the y-intercept. And if this were not a nice, pretty integer, I would not use the y-intercept. I would have used some other point, because I got other points that are nice, pretty points, like my x-intercepts. All right, let's write our equation in vertex form. Now, if my equation is not exactly the same in vertex form and in intercept form, remember that I had to estimate on the vertex form here. I had to estimate on that vertex. So we did our best little estimating, but we might be a teensy bit off if it's really not a half. Right? So if we don't get the same a value for vertex and intercept form, when we go to write the equation in standard form, we're not going to get the same equation. But no, that's just because we were a little off in our estimating here. All right, so step number 1, the formula, y equals a times x minus h squared plus k. All right, let's replace the h and the k and the x and the y. So we have negative 3 equals a times 0. That's going to be minus a negative 1/2. That's plus 1/2 squared. And then minus 7 halves. All right, so now let's simplify in our parentheses. Negative 3 equals, so that's going to be, that's just 1/2, right? And 1/2 squared, that's 1/4. So 1/4 a minus 7 halves. Now I'm going to have to change that negative 3 to halves. So I want it to still be equal to negative 3, but have a denominator of 2. Well, then the numerator is going to have to be negative 6, because negative 6 halves is the same as negative 3. All right, so now we can add 7 halves to both sides. So that gives us 1/2 equals 1/4 a. And now if we want to isolate a, we're going to have to multiply by the reciprocal. So we're going to multiply both sides by 4. So half of 4 is 2. All right, so 2 is equal to a, and that means our equation in vertex form is going to be y equals 2x, so minus a negative 1/2, that's going to be plus 1/2 squared, and then minus 7 halves. I feel pretty good because we got a nice number. Maybe we did a really good job estimating. Let's do the same thing, but now it's going to be intercept form. And then after that, we'll change it to standard form. So we have y is equal to, and then of course intercept form is a times x minus p times x minus q. Let's just use that very same point. And since it's a nice number, that's a good idea. I certainly don't want to use the vertex again. So let's use that y-intercept. We have an x-intercept at negative 2, 0. So that's going to be our p is going to be negative 2. And we have another x-intercept at 1, 0. That'll be the q. All right, now let's just replace those values in our equation here. So we have negative 3 equals a times 0 minus a negative 2. So that's going to be a plus 2. And then 0 minus 1. So we have negative 3 equals, now I was feeling so good because I got a 2. Got a 2 and it was in vertex form. And we're not going to get the same value, are we? So we have a times 2 times negative 1. So we have negative 3 equals negative 2a. And then we divide both sides by negative 2. So a is, we get 3 halves. So what does that tell us? That we did not do a great job estimating our vertex. But we did the best job we could, right? So I will try not to ever give you one where you have to estimate it like that. But if I do, and you estimate it to be a half, well, that will be good enough for me, because it's hard to estimate. You can't tell exactly when you're trying to estimate where that point really is. So I'm just going to double check and make sure that I don't see any boo-boos, but unfortunately I don't. And so I wanted them to be the same so that you can see the comparison. This doesn't work well for the H and K. I should have chosen a different graph where we could find our vertex clearly. All right, so, well, it was pretty close. And so what we'll do is, we know one of those is right. Oh, let's finish writing our equation. So y equals 3 halves times, oops, y equals 3 halves times, and this would be x plus 2 and x minus 1. All right, so we know this has a boo-boo in it. So I will show you how to write that into standard form using a different format. I would have just done a different problem, except this one's in your notes anyhow. So know that if you have to estimate, you might not be exact. And the number's even nicer. All right, so we will just write underneath this one that we estimated. So that's why we're not exactly the same. All right, so let's take a look at this one. This is our equation in standard form. Intercept form. What if we want to change it to standard form? Well, then we just need to multiply and distribute, right? So that we don't have any parentheses. So we have y is equal to 3 halves. Let's multiply the x plus 2 times the x minus 1. All right, so we have x times x minus 1. And we have 2 times x minus 1. I just have to write on my vertex. So we have y equals 3 halves times x squared minus x plus 2x minus 2. All right, so we should combine the like terms. Y equals 3 halves times x squared, that'd be plus x minus 2. And then we just distribute the 3 halves to everybody. So y is equal to x squared, or excuse me, 3 halves x squared. Three halves x squared. So 3 halves times x, that's just going to be plus 3 halves x. And then 3 halves times a negative 2, the 2's will cancel, so it's just going to be minus 3. So we can feel really good about that equation. That one has the right y-intercept. So this is our equation in standard form. We have an estimating error up on the other one, right? That's why I always tell you, don't estimate, because we have an error up there. Well, we had to, so we did our best. If I figure out where that vertex is exactly located, I will redo this problem in class so that you can see what it was. For practice, because because that's my last problem, let's rewrite one of the equations that we know is right in standard form from vertex form. So let's rewrite this one into standard form, okay? So because we could check this one by looking at our graph. All right, so I'm going to use, oops, I'll keep that just the way it is. And I will put it down. If I move this one, then I'll have a little bit more space. All right, and so now we're going to go from intercept form to standard form. So if you're going to intercept form, if we're going from vertex form to standard form, keep saying the wrong ones. All right, so if we want to go from vertex form to standard form, the very first thing we're going to have to do is expand that square. So we have y equals, we're not going to do anything with the negative, so that's going to be x plus 1 times x plus 1, and then plus 4. So let's first multiply. So we'll have an x times an x plus 1, and a 1 times an x plus 1, because we've got to distribute everything in the first binomial to everything in the second binomial. And then we have a plus 4 at the end. Notice that is not multiplied by that negative 1, right? Because that negative 1 is only in front of the x plus 1 squared. So we have y equals negative times x squared plus x plus 1 plus 4. Let's combine our like terms and distribute the negative 1 all at the same time. So y equals, because it's not that hard to multiply by a negative, so we're going to have negative x squared, x plus x, that would be 2x, but now we distribute the negative, that's going to be a negative 2x, and then distribute the negative to the 1, that's going to be a negative 1. And then now we have the plus 4. So now all we have to do is add those two like terms. As I give ourselves more space, y equals negative x squared minus 2x plus 3. And notice that matches our y-intercept. So this one is in standard form, and that one is correct because we didn't do any estimating there. I actually should have put that in green, make it stand out, huh? So this is standard form right there. The one up here is vertex form, and it says it right there, so I won't write it again. And then in red we have intercept form. 3 different equations, all describe the same graph. Right? So you can go right from the graph or right from the vertex and a point, or the x-intercepts and a point, and write it into vertex form or intercept form. You can't write it in standard form right from the graph. Right? There's no way you're going to be able to figure out A and B. You can figure out C, but not A and B from the graph. So we always write it in vertex or intercept form first, and then change it to standard form. If you have a choice, I always like intercept form. Well, that's the end of this podcast, and the end of this end of my graphing quadratic functions lessons in class, or right now, if you want, or you can look on Schoology, will be these problems, and you're going to write the equation in vertex form or intercept form, or in vertex form, intercept form, and both to standard form. Now, you won't have a problem writing it in both intercept form and vertex form because you don't have to estimate the vertex or the x-intercepts. They're nice and clear on all of the graphs I've given you, right? And if it wasn't clear, then, like for instance, you couldn't possibly write number 2 in intercept form. There's no x-intercepts, so I didn't ask you to. Now, if we look at our graph here, appears to be a smidge more than being at 0. So let's just, for simplicity's sake, you know what? I will replace this graph because look at that. Rather than you having to estimate or us having to change it, that's not so nice in vertex form either. So I'll change that graph for you. Either that or we'll call that, we'll have to move that vertex over. But we'll change that one for you. So don't worry about number 2. I'll give you a new number 2 where that vertex you don't have to estimate. But the rest of these graphs, they're all good for vertex, intercept, or both. All right, so bye for now.